Hey class, welcome back to the lesson on three-dimensional figures and cross-sections. This is our third video because we're going to spend some time on cross-sections themselves. We've already discussed vertices, faces, and edges. We already discussed Euler's formula and how it relates to both 3 dimensions and 2 dimensions. And now we're going to dive into cross-sections. So we should first figure out what in the world is a cross-section. Now I'm borrowing this note from Miss Krista Book. She's one of our rock star teachers in our faculty, and she's an amazing person. I borrow her stuff quite a bit. So this is from Miss Book's set of notes, and it's just beautiful the way she put this together, so I'm going to borrow it. A cross-section is the intersection of a solid and a plane. So it's like if you're cutting a solid, that's a cross-section. And you can think of a cross-section as a very thin slice of the solid. And this is the first diagram that I want to focus on. Imagine an orange was cut, and the cross-section of the orange is this circle. Okay, so the cross-section, in fact, makes a circle. And so we want to keep that in mind. This is the concept of what is happening, but we're working in flat things. We're working on pieces of paper, we're working on computer screens, and we're discussing cross-sections. So again, the key element of your understanding is the ability to visualize what is happening. So a neat thing about your brain. So I'll discuss these diagrams super quick, and then we'll get into some examples. So if we take this pyramid, we have a rectangular pyramid, and we think about a horizontal cross-section, a cut across the horizon. What shape would that horizontal cross-section make? And then we look down upon that cross-section. The cross-section would make a rectangle, right? Very similar to the base, as a matter of fact, and in fact similar to the base. And so when we think about a horizontal cross-section that's through that pyramid, it'll make a rectangle. What about this if we took this particular polyhedron, like a triangular tube, but a tube, and we make a vertical cross-section, like a vertical slice right through that thing. We're visualizing a slice, and we look at the cross-section itself. The cross-section, in this case, would make a triangle. Okay, so in this case, the cross-section would make a triangle. And we're going to have to be able to visualize what is occurring in each instance. And so in a wrap-up for the note, many types of cross-sections, but the major ones we'll talk about are horizontal cross-section, and if we make a horizontal cross-section of a cylinder, we get a circle, or a vertical cross-section, Now this is the understanding that you must have. If it's a vertical cross-section, even if it's a cylinder, I know you're all wrapped up about, well, it's a circle base. That's true. Excuse me. But if you cut that thing vertically, if you cut that cylinder vertically and look straight at it, you're going to have the cross-section being a rectangle. So if you look straight at, like basically take a soda can and look straight at it, you will have a rectangle. Okay, so if you look at it from the top, it's a circle. From the side, it's a rectangle. That's what a cross-section is. So let's do a couple of examples real quick so we're familiar with the concept. So we picture this cylinder laid on its side, and we are being asked what the cross-section forms when we have this particular solid figure and a plane. So we're taking a cylinder, we're cutting it across, and we're gonna pretend we're looking down at it or look straight at it from the perspective of the can. What would we see? Remember, this is visualization, and so in this case, what we would see is a rectangle. Okay, so this is the cross-section in this particular diagram is a rectangle. Okay, so we would be able to see that. So if we look straight at it, that's what's happening here. Now what about this funky bowl looking thing? It's like a bowl here, right? So we have a solid at the right. What's the cross-section formed by a horizontal plane? So horizontal, if we were to cut this horizontally, tick, 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 horizontally, and we imagine there's a horizontal plane going through it, what would it make? And hopefully you can visualize the fact that when we look straight down at that cut, it's going to make a circle. Okay, somewhere between the size of the circle that makes the base and the top. Okay, so the horizontal plane would be a circle. Now, what about a vertical cut? Could you imagine what a vertical cut would be? So if we cut it straight down this way. Okay, so a vertical cut, what might that look like? And so if we were looking straight at the bowl, right, if it was a vertical cut, we were looking straight at the bowl, hopefully you can imagine the vertical cut would make a trapezoid. Boop, boop. That is what the shape of the vertical cut would make, a trapezoid. And you have to be able to visualize that, right? So imagine, a cut going across the top and, across the middle of the bottom, and it's making this plane, and you're looking straight at it, it would make the picture of a trapezoid. So we have to be able to visualize what's happening with cross sections, because it's very, very fun stuff to make your brain work that way, right? Right. So that's the concept of cross sections, and that wraps up the lesson. But we can do a little bit more of it. So let's do some more visualization. Here's a cube, and what we're going to do is draw a cross section formed by a vertical plane cutting down, but it's intersecting the front face and the right face. Okay, so imagine the front face and the right face. Okay, so this face here and this face here, and we're going to cut it. Okay, so we're going to cut down where it's intersecting just both of those. So can you imagine a cut? Can you visualize a cut that goes here and then straight down vertically? It would also cut through that as well. And so we would have a slice here and then a slice going through here. So that's exactly what's happening with a cut, vertical cut, that intersects both the front and the right face of the cube. Now, what shape would the cross section be? You look straight at that cut. Okay, so we're going to look straight at that cut, and what do you think we'll see? We're going to see a rectangle. Okay, that's exactly what we would see. We would see this particular rectangle, not the whole square, but when it intersects both the front and the right, it'll make a rectangle. So hopefully that makes sense. And then here's another question. We're going to draw another cross section, but this time a horizontal plane, horizontal plane intersecting the left face and the right face of the cube. So it's going to be intersecting the left and the right. So we're going to look at the left face and the right face. And it's a horizontal cut. So imagine a horizontal cut going through the left face and the right face. Okay, so that's what's happening. The one in blue. Okay, so what's the shape of this cross section? Well, where it cuts, it'll meet across the front here, and then it'll meet across the back there. And what shape is that going to make? It's going to make the same size square of the top and bottom face. So what's the shape it's going to make? This one will be looking down, right, because it's a horizontal cut. We'll be looking down, and it'll make a square, the exact same square that makes up the top and bottom face. So that is a square. Pretty cool, huh? So we're visualizing. That's the key. All right, let's do a quick little quiz, and we'll wrap this unit up. So here's like an example of what we might see on standardized tests. Standardized tests. Anyway, you know how I feel about them. So here we have a diagram going on. What's the cross-section formed by the plane and the solid figure below? Hopefully you can see there's a horizontal plane, and so we'll be looking down. And when we look down, what would we see in this particular example? We would see a circle. Okay, you have to be able to visualize that. Don't get fooled by the fact that it's 2 dimensions. This is visualization. And then for the last question, we'll wrap this up to see if we can remember Euler's theory, or Euler's theorem. For the polyhedron, okay, so Euler's theorem talks about the number of faces. So we got in this slice of cheese with the front, 1, 2, 3 around the side, and then 4, 5. So there's 5 faces. That knocks out B and that knocks out D, okay? The next is the number of vertices. So we have 1, 2, 3, 4, 5, 6 vertices. That's not A, so that is C. Must be the answer. I don't even need to know what Euler's theorem is. So that's how you cheat standardized testing. This is why I don't like them. So I'm out. Hopefully you enjoyed this lesson, and you now know what you need to know about 3D figures and cross sections. Peace out.